So now that we've discussed perfect squares and square numbers as a whole, let's discuss something that's known as square root notation. Now, in mathematics, we are constantly dealing with opposites. And when we are squaring numbers, the opposite process to squaring a number is the square root of that process. So what that essentially means is when we're looking for a square root, we're looking for a number that when it multiplies by itself, it equals the number that we're square rooting. So for example, if we're looking for the square root of 9, we are essentially looking at what number multiplies by itself to equal 9. Now, you might instantly think to yourself, well, that's going to be equal to 3. Visually speaking, just to connect it back to the previous video, we'll leave it in red for now. We can think of how would we form a square, a perfect square with exactly 9 little building blocks, 9 little squares. Well, we would build it like this, all right, which is going to be a 3 by 3. Okay, so we can instantly see here, let's just switch up to blue, that 9 is equal to 3 times 3. So if I wanted to find the square root of 9, okay, which we write like this. So this little symbol here is our square root symbol. What that question is essentially saying is what number multiplies by itself to equal 9? Well, we've just worked that out, that number is 3. When we multiply 3 by itself, it equals 9. And that's what square rooting is. So if we looked at the square root of 64, what I could do, visually speaking, is draw a perfect square that has exactly 64 little squares inside of it, a little bit like what I did with this 9 here. However, you can instantly see that's going to take a really, really long time, which is the reason why I did suggest in the last video, it's really good to know and get to know what your perfect squares are. So let's start listing them. If we have 1 squared, that's equal to 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64, which is what we're actually looking for. But let's just quickly go to 10. So 9 squared is 81. 10 squared is 100. In fact, we might as well complete the 12. 11 squared is 121. 12 squared is 144. The reason I've listed these is this is really useful to have sort of written down while you're getting to know these numbers, because when we're starting to square root numbers, and these come up quite a bit, it's really useful to be able to identify a perfect square so we can quickly identify what the square root of that number would actually be. So we know that 64 can be written as 8 squared or 8 times 8. So what that means is if we're going to square root 64, it's looking at what number multiplies by itself to equal 64, which in this case is going to be equal to 8. Now, like I said, the quickest way to be able to identify this is to know your perfect squares off by heart, which you get by just sort of using them more and more and more, to be completely honest with you. Now, what happens though if we want to find the square root of a number that isn't a perfect square? So, such as the square root of 30. If we looked at our previous list that we just had, we would notice that 5 squared here is 25, 6 squared is 36. 30 is somewhere between those two numbers, all right? So what this means is we don't have a whole number that exactly when we multiply it by itself equals 30. However, what we can sort of say about this is it has to be somewhere between 5 and 6, simply because 5 squared is equal to 25, 6 squared is equal to 36. It's sort of halfway in between. So we would have to say that the square root of 30 has to be somewhere, so it's approximately equal to between 5 and 6. And because it's about halfway, I would actually say it's approximately 5.5. okay, is somewhere halfway in between, but we can definitely say that it's going to be greater than 5. So the square root of 30 is going to be greater than 5, but it's going to be less than 6. We'll talk about these symbols in another video, but that's another way, if you've seen those greater than or less than symbols before, that we could actually write it. However, being able to estimate roughly where it's at like this is a really handy process to be able to do. Now let's have a look at the other number that we've got here, this square root of 103. Well, if we're looking at nearest 2 here, we know that 10 squared is equal to 100. We know that 11 squared is equal to 121. Now, yes, our square root of 103 will have to be somewhere between 10 and 11. However, you'll notice that 103 is much closer to 100 than it is to 121. So our answer is going to be much closer to 10 than it is to 11. All right, so it might be 10.1, 10.2 if we're giving some kind of estimate to it. But we can estimate that the square root of 103 will be approximately 10, you might just say 10.1, something like that, just to indicate that it is a little bit greater. If I went to the nearest whole number, I'd say it's approximately 10. So this is the reason why knowing these perfect squares off by heart is a really, really handy thing, because when we start dealing with square root and square root notation, which is what this is, it's really handy to be able to identify what number, roughly, are we actually talking about when we talk about the square root of 103, for example.